Hi, ladies and gentlemen. Notes 1.7 are the last set of notes for Unit 1, but it's probably the most important set of notes, so please make sure you're paying really close attention to what's happening in this set of notes. So the first thing that we want to do is consolidate all the information that we've put together based on what we discussed in class, based on the graphing calculator activity that we did, all that kind of stuff. So the first thing it asks you to do is write the general equation of a transformed function, and this is how we would write it out right here. So y equals a times f of k times x minus d plus c. Now, this looks really scary at first, but don't let it scare you. It's just putting together everything that we figured out. So the first thing that I want to talk about is the a value. So if you remember when we did a, when we multiplied, for example, if my parent function was y equals x squared, if we did y equals 2x squared, it made our graph skinnier. And if we had y equals 1/2 x squared, it made our graph wider. So remember, this right here is going to be your vertical stretch. So A tells you what your vertical stretch is going to be. Okay, it's either a vertical stretch or compression. If you remember, we filled this out. This is transformation number 3 on our paper. Or it could be a reflection in the x-axis. Okay, so if you remember right here, this is the parent absolute value function. If I have g of x is equal to 2 times the absolute value of x, my graph is now skinnier, right? And if I do h of x equals 1/2 times the absolute value of x, my graph is now wider. And if I do k of x is equal to negative absolute value of x, my graph is now a reflection of the red graph right here in the x-axis, okay? So if the negative's on the outside, if it's the a value that we have right here, then it's a reflection in the x-axis. So one thing that I just want you guys to write down, though, is that a is the scale factor, okay? So that's what you're multiplying by. A is our scale factor, and if a is between 0 and 1, just like we said in the last video, that means that it is going to be a compression. And if a is greater than 1, that means that it's going to be a stretch. Okay, and this is the absolute value because regardless of whether it's positive or negative, it's still going to compress it or stretch it. Okay, and then if a is negative, so if a is less than 1, then it's a reflection in the x-axis. Okay, all right, so now we're done with A. The next thing that we have is F, but remember F right here is just the rule, just like we've learned with function notation. So now we have K. So K right here is what happens when you multiply the X by the K value. So let's go ahead and take a look at some examples of that. So right here, if I were to do absolute value again, but this time I were to multiply the x inside of my absolute value by 2, my graph becomes skinnier. But this time when my graph becomes skinnier, that means it's getting pushed inwards. Right? So if you remember, this is actually a compression because my graph is getting pushed inwards. And then if I have h of x is equal to the absolute value of 1/2 of the x right here, then my graph becomes stretched out horizontally right here. So K right here is going to be your horizontal stretch or compression, or we could also have a reflection, but this time it's not in the x-axis. The reflection is, let's see, we get k of x is equal to the absolute value of negative x. It looks exactly the same because, let's change the color so we can see that it's the same thing right here as the red one up here. It's the exact same thing because it's reflected over the y-axis. It's already symmetrical, so you can't really see the reflection, but it still works, okay? So right here, the one thing that's really key, if you remember from the last video, that 1 over k is the scale factor, and that's really important to make sure that you know. 1 over k is the scale factor, okay? And then just like we said before, 0 is less than the absolute value of 1 over k is less than 1. So if 1 over k is between 0 and 1, it is a compression. But this time when we compress it horizontally, it actually looks like it's getting thinner because you're pushing it inwards as opposed to pushing it downwards, okay? And then if 1 over k, the absolute value of 1 over k is greater than 1, then it's a stretch, okay? And if 1 over k is less than 1, then it's a reflection in the y-axis, okay? All right, so now the next piece that we have, so we're done with A, we're done with K. These pieces are our scale factors pretty much, okay? Now the next piece that we want to talk about is D. So this is X minus D, and if I have minus D right here, since it's included with the D, don't forget, or included with the X, don't forget that D is going to tell you your horizontal shift. And the reason why it is minus D is because it's always the opposite direction, okay? And then C is going to tell you your vertical shifts. Okay? All right, so let's apply that to question number 1. All right, in number 1, it says to sketch the graph of f of x equals -3 times the square root of 2x plus 8 minus 1 and describe all the parent function, or all the transformations of the parent function that results in f of x. And then we're going to find the domain and range. So the first thing I need to do is determine what my parent function is. And I know that my parent function is going to be the square root of x. Okay? Next thing I'm going to do is I'm going to get this in the format of the equation that we have up here. The general equation of a transformed function. So if the general equation of a transformed function is going to be y equals a times f of k times x minus d plus c, I'm going to look at this function right here and I'm going to figure out what it's saying. So notice how the k is factored out of this x minus d. Notice how this 2 is not factored out. So we need to factor that 2 out first. So I'm going to write this out as f of x equals -3 times the square root of 2 times x plus, and then when I factor out of 2 from the 8, I get a 4, okay? I'm going to close my brackets, and then I have a -1 at the end. Now that I've done that, I'm going to identify each one of my parameters, the a, the k, the d, and the c. So I know that a is going to be equal to -3. What does that tell me? Well, first of all, because it's negative, I know it's going to have a reflection in the x-axis, okay? So right here, this is telling me that I will have a reflection in the x-axis. I also am being told that because it's 3, because it's greater than 1, the absolute value of -3 is greater than 1, I'm going to have a vertical stretch with a scale factor equal to 3, okay? Essentially, what this is saying is multiply, because this is vertical, y by -3, okay? All right, so now that we're done with that, the next thing that we're going to do is we're going to identify what k is. Well, k is equal to the number 2. So what does this tell me? First of all, because k is positive, there's no reflections going on in the y-axis. Now I need to figure out what my scale factor is going to be. Now, if you remember, in order to figure out the scale factor, I have to do 1 over k. So I'm going to do the reciprocal of whatever the k value is. So here, my scale factor is equal to 1 over 2, which means that it is a horizontal compression. So here we can say that it is a horizontal compression. What does this mean to do? I just have to multiply my x values by 1/2. So let's start by doing that first. We're done with the first two parameters. Let's identify how to apply that to our parent function chart. So since our parent function is the square root of x, we're going to use the values 0, 1, 4, and 9 because those numbers are evenly square rootable. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. So when I go ahead and I multiply x by 1/2 and I multiply y by -3, these are the values that I end up getting. So x here, y here. 0 times 1/2 is 0, 1 times 1/2 is 1/2, 4 times 1/2 is 2, and 9 times 1/2 is going to give me 4.5 or 4.5. And actually, let's make this 0.5 so that way we're consistent with our decimals, okay? Now, 0 times -3 is 0. 1 times -3 is -3. 2 times -3 is -6. And then 3 times -3 is -9, okay? Next thing I want you to do is just to set up your graph with your x and your y axes labeled. Make sure you don't forget to do that. Also, make sure you label 0, and then you have to indicate what your scale is. And I think it would be a good idea for us to go by ones. So I'm going to just label a few numbers right here, but knowing each unit, each block is equal to 1 unit. Okay? All right, now that I've done that, the next two parameters that I need to identify are D and C. Okay? So I know right here that D, when I look at my equation right here, my D value is going to be -4. So that means that it shifted left 4 units, okay? And then here, when I look at this right here, I can see that C is -1. So I can say C equals -1. So that tells me it shifted down by 1. Okay, so now what I'm going to do is I'm going to take my chart that I have here and I'm going to do the same thing. I'm going to subtract 4 from x, okay, and I'm going to subtract 1 from y, and that's going to give me my shifts. So if you notice when we do our charts, we always want to do our compressions and our stretches first, our scale factors, our multiplying first, and then we want to do our shifting second, okay? So let's go ahead and create our new chart right here. So we've got x and we've got y. And so when I subtract 4 from 0, I get -4. When I subtract 4 from 0.5, I get -3.5. When I subtract 4 from 2, I get -2. And when I subtract 4 from 4.5, I get 0.5. Okay? And then when I shift these guys down, or when I subtract 1 from each one of these guys, 0 minus 1 is -1, -3 minus 1 is -4, -6 minus 1 is -7, and -9 minus 1 is -10. So this is going to give me enough points to be able to plot my graph. So let's go ahead and do that. So -4, -1 is going to be right here. Okay, -3.5, -4. I'm going to go to the left 3.5, and I'm going to go down 4. And you guys know how to graph. So go ahead and finish graphing while I finish graphing up here. And then I'm just going to label this as f of x equals -3 times the square root of 2x plus 8 minus 1 on the outside. Okay? I want to discuss this a little bit more with Desmos really quickly, and then we'll move on to the next question. Okay, so the first thing I'm going to do is I'm going to start with my parent function. So the parent function says the square root of x. Okay, so that's what we have right here. Now, the next thing that we noticed is, or the next thing that we identified was that a was -3, which means that it's going to reflect in the x-axis and it's going to stretch with vertically by a scale factor of 3. So I want you guys to notice how right here we end up getting -3 times the square root of x. And by looking at my graph right here, you can tell that it reflected over the x-axis and that it also stretched. It's going up at a faster rate, or here I guess we should say it's going down at a faster rate. So that right there is going to be my reflection and my vertical stretch. Okay, so that's the green one. The next thing that we figured out happened was that it's going to get horizontally compressed. So it's going to get pushed in with a scale factor of 1/2. And that's where this 2 came from right here, or this 2 right here. So if I write f of x equals -3 times the square root of 2x, if you notice right here, my graph now is getting pushed closer to the y-axis because it has a horizontal compression. Okay, all right, and then the next piece is that it shifted 4 units to the left. So here I'm going to say f of x equals -3 times the square root of 2 times x plus 4. So if you notice right here, when I look at my graph, the orange graph got shifted 4 units to the left and is now the purple graph. So this is the series of transformations that we're going through. And then lastly, c equals -1, it got shifted down 1. So the last thing I'm going to do is I'm going to say f of x equals -3 times the square root of 2 times x plus 4. And then the -1 goes at the end. So that's this black graph that we have right here, which is the purple graph shifted down 1. Now our black graph is essentially right here, this graph that we have here is essentially our final product, and that's what we ended up getting when we graphed it out on our paper over here. Okay. All right, the last thing that I want to do is identify the domain and the range for these functions. So when I look right here, I can figure out, well, my domain is going to be any real number, but it has to be bigger than this value right here, this -4 right here. So x is going to be greater than or equal to -4, okay? And then my range, I can see right here that my range is going to be anything below this line right here. So y is an element of the real numbers as well, but y is less than or equal to -1. Okay, so those are my domain and range. Some transformations are applied in order to the reciprocal function f of x equals 1 over x. So this right here is going to be our parent function. Okay, so if it's a horizontal stretch by the factor of 3, and let's just write down the equation again on top so we know what we're talking about. So y equals a times f of k times x minus d plus c. So a horizontal stretch is our k value, and the scale factor is 3. And remember, in order to figure out our k value, we have to take the reciprocal of the factor. So that means that k would be 1/3, okay? And then if we have a vertical stretch by the factor of 2, remember a tells us what our vertical stretch is going to be. So a is going to equal 2, okay? If we have a reflection in the y-axis, remember that is going to also affect k. So if k was originally 1/3, now k is going to be -1/3 because the reflection in the y-axis negates our x values right here, and that's what x is being multiplied. It's being multiplied by k, so k becomes -1/3, okay? And then if it's translated 5 units to the right, that means that d equals 5 because this is our translation to the right, our horizontal shift. And then 4 units up, that tells us that c equals 4. Okay, so now that we've done that, we want to write the equation of the transformed function g of x, okay? So how do I do this? Well, we know that g of x is going to have a scale factor, a k value of 1/3. Well, actually, sorry, we should say that our k value is -1/3. We also know that a is 2, and we know that d is 5 and c is 4. So and our parent function is 1 over x. So let's do the a part first. To multiply 1 over x by 2, it essentially becomes 2 over x, right? So right here, we know that it's going to be 2 over, and then here, inside of the brackets right here, this is saying that we have to do x minus d. So we know that x minus d is going to be x minus 5. But we have to multiply that by our k value, which is negative 1/3. Why do I have all of this stuff in the denominator? Because our input goes in the denominator for a reciprocal function. And all of this stuff is our horizontal changes, so that's my input. And then we just have a +4 on the outside. So this right here is going to be my g of x. So now it asks us to sketch the graph of f of x and g of x. So I'm going to just set up my graph again. Make sure you label x and y. I'll label this 0. I'm going to go by units of 1 again. So f of x equals 1 over x. And if you remember, this is what the parent function will look like right here. The key points that we have here are going to be -1, -1, as well as 1, 1. Those are two key points. It's also important to remember that we have our asymptotes at x equals 0 and at y equals 0. So if you look right here, I'm going to put those asymptotes in right here. So I'm going to literally draw in some dotted lines where my asymptotes would be. So we know we have an asymptote where y equals 0, and we also know that we have an asymptote where x equals 0. So the graph is going to try to touch those points, but it just is not going to be able to. Okay? We also know that we have the critical points 1, 1, and we also have -1, -1. And then our graph is going to look like this. This is our parent function right here. Okay, so sorry about having that in the way. This is going to be what our parent function looks like. Now, and we'll put these critical points so you can see what's happening. So I've sketched the graph of f of x. Now I need to sketch the graph of g of x. So we've got two critical points that we have here that are going to help us sketch this graph. So if you guys notice right here, the first critical point is -1, -1. And we know that it's being multiplied by a factor of 3, the x's, but it's also being reflected in the y-axis. So that means that we can multiply x by -3. And then if we have a vertical stretch with a scale factor of 2, that means that we can multiply y by 2. So that means that my new coordinate right here is going to become -1 times -3, which is 3, and then -1 times 2, which is -2. Okay, and let's do the same thing for 1, 1. We're going to multiply x by -3 and multiply y by 2. So this one becomes a -3, and this one right here becomes a +2. So that means, and I don't want you to actually graph these points out, I just want you to take a look at what I'm going to do right here. So that means that I'm going to go to 3, -2 right here. And then I'm also going to go to -3, 2. And because it's a reflection in the y-axis, this piece right here, this purple piece right here, will now be reflected in the y-axis, so it's going to end up looking more like that. Now notice how it looks different because not only is it reflected, but it's also horizontally stretched and vertically stretched. And then this piece over here also reflects in the y-axis, so it's going to end up looking like that. Now that's not the final graph though, because we haven't done our shifting yet. So I don't want to graph this out fully yet. So I'm going to delete these points in the graph, and now I'm going to do my shift. If it shifted 5 units to the right, what ends up happening is this vertical asymptote right here ends up moving 5 units to the right. So I'm literally going to take this asymptote, and it's now going to be at x equals 5 instead of at x equals 0. And also, since it shifted 4 units up, I'm going to take, sorry, not that. I'm going to take this asymptote right here, this horizontal asymptote, and I'm going to shift this 4 units up. So now I have an asymptote at y equals 4. Okay, so it's kind of like this origin right here gets transferred over here. Okay, now I need to do the shifting to my coordinates as well, my critical points. So if it shifted 5 units to the right, I'm going to add 5 to x. And if it shifted 4 units up, I'm going to add 4 to y. So this 3 becomes an 8, and this -2 becomes a 2. So I'm going to go to 8, 2, And this right here is going to be one of my new coordinates that I have right here. Sorry, I'm going to go to 8, 2. So this right here is going to be one of my new coordinates that I have here. I'm going to do the same thing over with this coordinate, negative 3, 2. So when I add 5 to negative 3, I get 2. When I add 4 to 2, I get 6. So I'm going to go to 2, 6, and here is my other coordinate right here. Okay? And if you remember, this piece that's decreasing right here is now going to be on the other side of my asymptote. So my graph is actually going to end up looking as follows. Okay, and then this piece that's decreasing over here is actually going to be on the other side of my asymptote and increasing because it reflected. So this is what my other graph is going to look like. We have this critical point of 8, 2, and then we have this critical point of 2, 6. Okay, so question C asks us to state the domain and range of both functions. So I'm just going to move this over here. Let's start with f of x. So for f of x, right here, if I look at my graph, I can see that my graph is going to touch every single x value, except it will not be able to touch this 0 right here. So I can say that the domain is going to be all real numbers except x can't equal 0. Okay? And then when I look right here at my range, all my y values will work, except it will never touch the x-axis, right? Or y equals 0. So my range is going to be f of x is an element of the reals, and f of x does not equal 0. Okay? All right, so now for g of x, let's find the domain in our range. So the domain right here is going to be same thing. When I look at it, all real numbers work until I get to this x equals 5. It'll never touch x equals 5. So I'll say that the domain is x is an element of all reals except x cannot equal 5. Okay? And then our range right here, I'm going to say that f of x is an element of all the reals, sorry, but not f of x, I should say g of x, such that right here, when I look at it, I've got values on the y coordinates until I get to 4, so y cannot equal 4, or g of x cannot equal 4. Okay, and that's pretty much what we need to do. Come with questions to class, and I will see you next time we have class. Bye.